Welcome everyone. Now we are going to start the topic momentum. This topic is from the chapter Motion in a Plane. Let's begin the topic momentum. So momentum, the motion of the body is represented by two physical quantities in dynamics. Dynamics means when the body starts to move, something which is related to the movement. Now, if I'm talking that momentum, so momentum comes or arises by the help of like kinetic energy or a momentum. There will be two terms. So when two stones are different masses dropped at the same height on the vehicle, okay, which cause greater damage. Again, I'm repeating. Those stones, okay, basically those stones have a two. Here we have taken two stones, okay. Both have different masses. For example, mass M1 and mass M2, okay, dropped from the same height on the vehicle, which cause greater damage. What's your answer? Okay, obviously the larger stone causes greater damage because momentum is directly proportional to the mass. Now the same question, I'm just dropping in any other word, okay? Like since large stone with greater mass applies a greater force even though both the stone have the same velocity when they touch the ground. If two stones have same mass but different height drops on the vehicle, which one causes greater damage? The question is a little bit, I'll just change. But the concept which you have applied, something will be interesting. What's your answer, students? Yes. The correct answer, the stone falling from the greater height produces greater damage. What's the reason of that? The reason is because the stone falling from the greater height will have a larger velocity. It applies a greater force. What does mean? That means momentum. Momentum means movement, okay, of any object have a greater velocity if they have a greater momentum. So P is directly proportional to V. Now, if two stones have a different masses dropped from the different height, which causes more damage, student? The stone have a larger mass dropped from the greater height causes greater damage. Since its product, okay, its product of a mass and velocity is larger. Finally, what we can say, the momentum of a body is defined as the quantity of the motion contained in it. That means it is measured as the product of a mass and a velocity. It is denoted by P. If mass of the body is small m and velocity is v, then its momentum is P is equals to mv. What is a P over here? P is momentum, m mass of the body, v velocity of the body. Now, what is the unit of m? Kg. Velocity v, meter per second. So, unit of momentum you can write as a kg meter per second also. We have another unit also. Clear? So, we will move on that. Unit of momentum. So, as we saw, momentum is a vector quantity that P, vector P is equals to m vector V. So, Cg is gram centimeter per second, SI kg meter per second, kilogram meter per second. Dimensional formula of momentum. So dimensional formula is mLT minus 1. If you have a problem to solve that particular term, kg we are denoted as a m for a mass, meter for a length, and a second for a t time. Now note that Momentum is a vector quantity whose direction is in the direction of the velocity. Newton's second law of motion. According to the first law of motion, if there is no external force act on a moving body, then it is a move to uniform velocity. What is the meaning of that? See, if the first law, according to the first law of motion, okay, that is the inertia, law of inertia. That means if any object is in rest, it remains at rest. If that will be in moving in a straight line, it remains moving in a straight line unless compelled by any external force or source. बिना फोर्स लगाए हुए हम किसी भी ऑब्जेक्ट की मोशन में चेंजमेंट नहीं कर सकते हैं. दैट इज द फर्स्ट लॉ ऑफ मोशन. ओके, सो देन it moves with the uniform velocity. If no external force act on the body, its momentum remains constant. Means the particle is moving and that particular momentum which actually that was a moving. Hence, when the momentum of the body changes, the body must under the action of a net external force. Newton's second law of motion states that the rate of change of momentum of the body is directly proportional to the net external force acting on the body and takes place in the direction in which the force acts. I hope this will be clear, students. If no, so I'm just telling you that more thing. The rate of a change of momentum means if momentum is continuously changes, for that I'm taking as a delta P, final momentum minus initial momentum is directly proportional to the net external force. Okay, so that means delta P by delta T is directly proportional to F. The first multiple choice question is momentum is the product of mass and acceleration, the product of mass and velocity, the product of mass and displacement, the product of mass and speed. The correct answer for this question is the product of mass and velocity. Second, if two stones of same mass from different height fall on a vehicle, which one causes a greater damage? Stone from the greater height, stone from less height? A and B are correct. None of these. The correct answer for this question is A, stone from a greater height. Third, what is the dimensional formula of momentum? ml to t minus 2, mlt minus 2, mlt minus 1 or ml minus 1 t minus 1. Student, I think you know about that because earlier soon we will did it. So the correct answer is C, ml t minus 1. Here is a little demo of that. Second law of motion. Second law of motion is the rate of a change of momentum of a body is directly proportional to the applied force and takes place in the direction of forces. So as you can see, a person is continuously hitting on their own leg also and he is continuously crying, ouch! What's the meaning of that? But if there will be a ball, he is actually doing fun. So the second law of motion tells that there is a net external force acting on the body. It relates the net external force and acceleration of a body occurs. Okay. Acceleration is a product of force and on the mass. The greater the mass of an object, the greater the force of an object. So as you see in the previous one, What they did, if you apply the force on that, this ball start to jump, as we see here. So acceleration is the product or produced when the force acts on the mass. Then the greater the mass, okay, is the greater the amount of force required the acceleration to the object. Everyone unconsciously knows the second laws. Everyone knows that heavy body or heavy object require more force or more distance for the lighter object. What does it mean? Newton's second law gives us the exact relationship between the force, mass and acceleration. That is what? It talks about how fast an object can move. Mathematically, second law equation expressed as F is equals to ma. That means mass into acceleration. Newton's second law of motion is the most significant law among all the law of motion. Second law measures quantity of the force, whereas first law of motion describes the concept of force. Okay. So second law measures what? Like how much force is applied actually. And first law of motion is that what is force actually. So unit of force is what? It is a gram centimeter per second square or dyne. In any case, we are saying kilogram meter per second square. Or we are saying Newton. 1 Newton is equals to 10 to the power 5 dyne. Yay. So define 1 Newton. We know that this formula is very famous, that is F is equals to ma. Okay. Now, if m is equals to 1, a is equals to 1 meter per second square, which is the unit of acceleration. Force 1 kg, 1 meter per second square, then we get 1 Newton. Okay. That means we can say if a force produces an acceleration of 1 meter per second square of an object of a mass 1 kg, then force is called 1 Newton, whose dimensional formula is mLT minus 2. Example, Ramu's car, which weight 1000 kg, is out of the gas. Ramu is trying to push the car to a gas station and he makes the car to move with an acceleration of 0.05 meter per second square. Using the second law, you can compute how much force Ramu is applying on the car. Like as you can see, force, we don't know the value of force, but mass and acceleration we know. So what kind of formula we will apply? We will apply the second law of motion, which is F is equals to ma. So the value of m is 1000 and a is 0.05. After solution, we get the force 50 Newton. Moving ahead with the multiple choice question, students. Which of the following is the most significant law of motion given by Newton? Third law of motion, second law of motion, first law of motion, or Newton's law of gravitation? The correct answer is Newton's second law of motion. Second question we have, a force produces an acceleration of 1 meter per second square on an object of mass 1 kg. This force is defined as a 1 dyne, 1 Newton, 1 Tesla, 1 pounded. The correct answer is a 1 Newton. If a force produces an acceleration of 1 meter per second square in an object of a mass 1 kg, then the force is called 1 Newton. And what is a 1 Newton? 1 Newton is nothing but when the value of a mass is 1 kg, a 1 meter per second square, then we get 1 Newton. Now we will do the derivation of a Newton's second law of motion. Statement of a second law, Newton's second law of motion. The rate of change of momentum, okay? The rate of change of momentum okay, the rate of a change of momentum of the body is directly proportional to the applied external force, okay, and takes place the direction of force. Means whenever your external force is applied on the particular body, the body start to move. Okay, so momentum is in the direction of force. That have some expression of Newton's second law. If under the action of external force F for time interval dt, okay, and the velocity of the body is v, and the mass of the body is m, so it changes from v to vector v plus delta v. Then the initial momentum will be mv and the change in momentum will be mdv. According to the second law, the rate of a change of momentum of any body is directly proportional to applied force. Okay, so what does that mean? The rate of a change means if we are changing the value, the rate of a change of means something which is divided by t. Okay, applies the force means that will be directly proportional to the applied force. F is directly proportional to the dp by dt. So if we remove the proportionality sign, we get the formula like k dp by dt. K is proportionality constant whose value is 1 actually. Okay, after the putting the value we will get. So the P is nothing but mv dv by dt. Okay. F is equals to k m dv by dt. M is a constant, that's why we will put outside from this differentiation symbol. So k vector ma, because vector A is equals to dv by dt, that we know. If k is equals to 1, then vector F is equals to m vector A. So unit of force, as we know that gram centimeter per second square or dyne is SI system, kg meter per second square or Newton. 1 Newton is equals to 10 to the power 5 time, and dimensional formula. I hope you remember, student, dimensional formula MLT minus 2. Okay. Gravitational unit of force, kilogram weight, and gram weight, also called as a gravitational unit of force. 1 kg watt or kgf is a 9.8 or a g Newton. 1 gram weight or gmf is 980 or a g Dian. Now move with the some multiple choice question. Okay, we already saw, but like what is the relation between force and acceleration? So we know the directly proportional. Okay, force and acceleration is directly proportional because the formula is F is equals to ma. Force and mass will be directly proportional. These two things keep in your mind. Okay. Next question. What is the SI unit of force? SI unit of force. That is a Newton. And what is the CGS unit of force? That is a Dian. Okay. So application of a Newton's second law. First, if u and v are the initial and final position or final velocities of the particle of a mass m and average force acting on the particle in time interval dt, so F is equals to m v minus mu by dt, that is dp by dt. Okay. So second, if the ball m strikes on a rigid floor normally and rebounds with the same speed v, then there is a change in linear momentum which is a 2mv along with the normal away from the floor. If the time of contact of the ball with the same with the floor, then the force of the ball will be 2mv by t. If ball of mass m strikes on a rigid wall with a speed v, making an angle alpha with the normal to the surface and rebound with the same speed at an angle m, at an angle alpha. So it will make an angle v cos theta and with sin theta. Okay. So there is a particular component which will be added down, which is a v sin theta. Okay. So then we can say that, okay, the magnitude of a change in momentum mv cos alpha, as you can see from this direction, mv cos alpha, and in this direction mv cos alpha again, but that direction is opposite, that's why we are taking as a minus. So here we can say 2mv cos theta perpendicular away from the wall. So change in momentum is 0 along the wall. Okay, that is a dp. V sin alpha minus V sin alpha is equals to 0 for that scenario. If time t is the angle of a contact, is the contact of the ball with the wall, then the force on the wall is C. अगर हम टी टाइम लेते हैं, ठीक है, जैसे सपोज टी टाइम लगा है बॉल को कांटेक्ट होने से, ठीक है, वॉल के, तो उतना ही टाइम लगेगा वॉल से उसको शिफ्ट होने के लिए, ठीक है. दैट मीन्स एफ dp by dt है यहाँ पर, तो मोमेंटम रिमेन्स कंजर्व. एंड फॉर दिस सिनेरियो पर्टिकुलर दिस प्रॉब्लम ऑल्सो वी कैन से एफ is equals to 2mv cos alpha by t. Same problem we are taking, but with the different scenarios. Okay. So as you can see in this situation, if a ball of mass m strikes on a rigid wall with the speed v, making an angle theta with the wall, and rebounds with the same speed in the same angle is same here. So for that scenario, what is happen? If the angle is different, we are taking in the previous issue like mv cos alpha, but here now the angle is same, then the magnitude of the change in momentum will be dp. Okay, is mv sin theta minus mv sin theta, which comes value which to mv sin theta perpendicular away from the wall. In this, momentum along the wall is 0. Since dp is equals to v cos theta minus v cos theta is equals to 0, if t is the time of contact of the ball with wall, force will be ball is 2mv sin theta by t. If theta is the angle between the direction of motion of the ball and the wall, then magnitude of a change in momentum of the ball perpendicular to the wall, which is 2mv sin theta. सिंपल सी चीज है, अगर हम एंगल लेंगे इसके बीच का, ठीक है, वॉल और बॉल के बीच का, तो यहाँ पर 2mv sin थीटा आ जाएगा. वेयर एज अगर हम इस एंगल की बात करेंगे तो यहाँ पर 2mv cos अल्फा आ जाएगा. आई होप दिस नाउ थिंग इज क्लियर. As you can see, from the nozzle of the area of cross section A, liquid of density rho coming out with the velocity v horizontal and strike with the vertical wall. Then, if water does not bounce back, that is, it drops down along the wall or force exerted on the wall. That means F is equals to AV square rho. If water bounces back the same speed, force exerted on the wall is 2AV square rho. Why I am just adding 2? Because as you can see, the velocity will be added. Initial v and the final after change in velocity, this will be 2v. So here the velocity added, so 2 this will becomes, or we can say momentum rebounds, so change in momentum will be 2p. Students, this is all much about for today's class. I hope you learn and you get some knowledge. Okay, so if there is any kind of issue, please ask me.